Now, for this lesson, we are starting a new topic of functions and relationship. And in this very specific chapter, we are going to be learning about quantities that can change while others don't change. We are going to be investigating relationships. We are going to be looking at how one quantity behaves, for example, as the other one changes. For example, are we going to say one quantity is increasing as the price, like as the other one is increasing? Or we are going to see that the other quantity is decreasing as the other one is increasing? You see? So the description here we are going to be having in general is like one quantity increasing as the other one is increasing. Okay? Or you will be having a relationship where one quantity is increasing as the other one is decreasing. There is also a relationship which will come up, which is about how one quantity increases as the other one does not change. So in functions and relationships, we are basically looking at, relationships, rather how quantities change. And we are going to be comparing these quantities. We will be looking at one quantity and we compare with the other quantity. Now, here is one example. For example, the height of a tree. As the tree gets older and older. Okay? Now, quantities that change, most of the time we are going to be referring to them as variable quantities. That is, quantities that can vary over time. We call them variable quantities, written as indicated here. Variable, okay, like this. So this is how we refer to a quantity which can change. Now, we may not refer to it generally as variable quantity. We may simply refer to it as what? As a variable. A variable, in simple terms in mathematics, is used to mean a quantity which can change in value. Like for example, I have indicated the height of a tree as the tree gets older and older. One thing you notice is as the tree gets older and older, like from the time it is grown, each year the height changes. You see, as the time or as its age changes, the height also changes. Now in this case, the height of the tree is called a variable quantity. Okay? So that is what we call a variable in simple terms. Now, it is always, a common thing to see that one quantity is increasing as the other one is increasing. Or simply, one quantity is changing as the other one is also changing. Like, for example, the case that I have indicated, that one of the tree and the age of the tree. So as time is increasing, as the age of the tree is increasing, as the tree is getting older and older and older, the height is also changing. And because of this, we can compare the relationship a lot more easily. One quantity is changing as the other one is changing. Well, we can also talk of things that we normally use. Like, for example, the longer you take on a phone call, the more you are charged. For example, if you're the one making the phone call, if you're calling someone, now as you call someone, the more or the longer you take on the phone call, the more seconds, the more minutes, you take making the phone call, the more the charges. Okay? Even if you had already bought, like bundle, call minutes, something like that, the more time you take, the more the minutes. And because the more the minutes, that means the more the charge. And before long, the call bundle will get done. You see that? So those type of relationships that will, directly be about things that we face every day and about things that happens around us is what we are going to be investigating in this chapter of functions and relationships. Well, the first thing we will then be looking at in this case is the constant and variable quantities. Now, constant in this case is used to mean it is not going to change with time. Okay, it's a quantity which cannot easily change with time. What are some of the things that do not change with time? Well, we will be looking at them. What are some of the things that change with time? We will also look at them. We will be looking at some few examples to help us have a better understanding of quantities that we refer to them as constant quantities or simply constants, and variable quantities or simply variables. So this is the first thing we will be looking at. That is constant and variable quantities. With the quantities, we mean basically everything you can relate with the other item. So this is the first thing we want to look at, which is constant and what? And variable quantities. Now, consider the following 7 situations which is listed here. There are 2 quantities in each situation. For each quantity, state whether it's a constant, that is, it doesn't change, or whether it changes. Also state, okay, whether the change of one quantity can affect the other quantity. That is, state the relationship between the 2 quantities listed in the items below. Okay? Now, if it has, try to say how the quantities are related. So you see, for every situation here, you have basically 3 questions to answer. The first question is for you to do what? The first question is for you to state whether the items are constants or they are variables. That is, for each quantity, state whether it is a constant or what. So for each question, we will be having 2 variables. Rather, we will be having what? 2 items, 2 quantities. Each question, 2 quantities. And for each quantity, you state whether it is a variable or it is a what? A constant. Then the second question is, are the 2 related? The third question is, how are they related? So now look at the first question, which is what? Your age and the number of fingers on your hand. Well, does your age and the number of fingers on your hand relate? In other words, look at your age and look at the fingers on the hand. If you are to compare these 2 quantities, which one is a constant and which one is a variable? Well, for this question, one thing we see is your fingers do not change with your age. Like, the fingers being this, and the other. These are the fingers. Do they change with your age? For example, when you're celebrating your 8th birthday, will you have more fingers? When you're celebrating your 10th birthday, will you have more fingers? You see? So in this case, fingers on the hand becomes the constant quantity, or we simply refer to it as a constant. And then in the second quantity, which is your age changes. It does. So the age becomes the what? The age becomes the variable quantity. So how do we write that? Well, we would like to call this activity 1. So in activity 1, Just trying to clear the board so that we can write nice. All right, there we go. So for activity one, we have two quantities, okay? The first quantity, okay, that is quantity one. We are going to, it's the what? It's the fingers. Then quantity two is the what? Quantity two is the age. So what do you say about the age and what do you say about the fingers? Well, fingers do not change with age. And so we would like to call it a constant. What? Constant quantity. Then the next thing is the age. Does your age stays the same? No, your age changes with time. So your age becomes the what? The variable quantity. Or simply the variable. Well, the next thing I would like to call this part A, like that. So that is the next case. Okay, I guess this is what I want to do. Right. So now in the second case, still under activity one, we are supposed to do what? We are supposed to show if these two quantities are related. Are these two quantities related? Is your finger, like the age, is your age related to the finger? The question is how, if they are related, okay? How, if they are related. So let's, sorry, this is another activity that I have prepared. Yeah. So really quick, here we go. The number of fingers, yes, the two quantities are not related. There we go. The quantities are not related at all. Yeah. So we say your age and the number of your fingers, they are not related. They are not related. And because they are not related, the third part of the question, which would be activity one, part B, rather part C. Just have this. How are they related? Well, there is nothing to say here. Okay, so we say not applicable. Not applicable is used to mean we can't do that. So we can now move on to the second activity, which is what? Which is activity two. Well, in activity two, part A, what are we looking for? The number of calls you make and the airtime left on your phone. Okay, so there are two quantities there. The first quantity being what? The number of calls. The second quantity being airtime left, right? So let's have it down here. So we have two quantities. Okay, quantity one is the number of calls, okay? So we say number of calls. Number of calls that you make. Then the second quantity is airtime left. Quantity two is what? Airtime left. So we say the airtime left in the phone. Yes, these are the two quantities. Now, so the thing we want to talk about here is, well, we have already seen quantity one and quantity two. Quantity one being that, I would like to put this in a bracket. Yes, like that. And the second quantity being what? Airtime left. Now, the question here is, how do we define these quantities? Okay. Looking at the number of calls and the airtime left. Which one is a constant quantity and which one is a variable quantity? Well, it turns out that the number of calls that you make can increase or can decrease. Airtime left very much depends on the number of calls you have made. So what do we say here? Well, the number of calls is not a constant, it's a variable. It can change. How about the airtime left? Well, the airtime left will also depend on the number of calls. So if the number of calls can change, then the airtime left in your phone can also change. And so we also call this what? A variable quantity, or simply a variable. Now, the next question is, how are they related? Okay? How are the two quantities related? So this is going to lead us to activity 2, part B. How are the two related? Well, are they related? Yes, they are related. We say the two quantities are related. What? The two quantities. Are what? Related. The next question is how. Okay, how are the two related? This is now going to be question 2, part C. How are the two related? Well, they are related in the sense that as the number of call increases, the airtime left decreases. Okay, because they're asking the how, so they want you to describe how the two quantities are related. So we say as the number of calls, as the number of calls increases, as the number of calls does what? Increases, airtime left decreases. Airtime left decreases. That is how they are related. The first thing was which one is a variable quantity and which one is what? Is not a variable quantity. You know, all of them are what? Are variable quantities. So that is for question 2. All the quantities in question 2 being the number of calls and the what? Being the number of calls and the airtime left. They are all variable quantities. All of them can change. The next thing here is, are they related? Yes, the two quantities are related. And the other thing is, how are they related? Well, as the number of calls increases, the airtime left decreases. That is how they are related. Now, in the third activity, we have the length of your arm and your ability to finish mathematics test quickly. There are two quantities there. The first one being what? The first one being the length of your arm. Yes, the length of your arm being the first quantity. So let's have this here. We are going to call this what? This is going to be our third activity. So this is activity. This is activity 3. Right here. Activity 3. So in activity 3, well, what are the quantities that we are talking about? The first quantity, that is quantity 1, is the length of your arm. Well, then the second quantity, that is quantity 2. What's the second quantity? Well, let's check. The second quantity here is your ability to finish mathematics test quickly. That is how fast you're going to do it. Let's put it here as the second what? The second quantity. Well, the question now is looking at the length of your arm. That is how long, okay? Whether you're using your left arm or your right arm, how long is your arm? And how is it related to how fast you can do a mathematics test? So looking at the length of your arm and the time taken to finish the mathematics test, that is how fast, which one can change and which one cannot change? Can the length of your arm increase or decrease? Or can the time taken to finish your mathematics test increase or decrease? You see, those are the quantities we want to talk about, the length of the arm and what? And how fast you do things. So we say the length of your arm cannot change. So this becomes what? A constant. Or simply a constant quantity, like that. Then the next thing is what? The next thing is your ability to finish this test really fast enough. So you can finish it fast, or you can finish it, you can take long. So yes, the length of the time or your ability to finish it fast can change. It is something which can change. That one now very much depends on how the question is. Are the questions generally so hard for you or they are easy for you? So you see, this becomes a what? A variable quantity. We simply refer to it as a variable. Well, now that is activity. That is activity what? That is activity 3, part A. Now, the next thing we want to look at is activity 3, part B. Are the two quantities related? Okay, we want to see if these two quantities are related. So we put here activity 3, part B, investigating the relationship. Are these two really related? Like how long your arm is, okay? If you're left-handed, how long is your left arm? Or if you're right-handed, how long is your right arm? Is the length of your arm related to your ability to finish mathematics test quick? No, they are not related. The length of your arm does not affect that. They are not related. Now, since they are not related, well, that means the third part of the question is not what? Is not applicable. So we say for the third part of the question, well, not applicable. Now we move to activity what? Activity 4. So activity 4, let's see what it's going to be. So we're calling it activity 4. Now for activity 4, let's first see. Activity 4, we have, yes, the number of identical houses to be built and the number of bricks required. Well, the number of houses, we could leave the word identical. Identical is just used to mean they look similar. So if the question is talking of the number of houses or identical houses and the number of bricks required. So it's very much like, when you look at these estates around, around the places where you live, the estates where you live, the more the number of houses inside, the more the number of bricks, right? Because each house requires bricks. So the more the number of houses, the more the bricks. So how many quantities do we have here? 2 quantities. The first one being what? The number of houses, okay? though they have added something additional here, the number of houses is one quantity. So we are going to write it as quantity 1, okay, as quantity 1 right here. So we are going to call this quantity 1. And quantity 1 is what? Is the number of identical houses. We will later describe it, whether it is what? Whether it is, yes, we will later describe it, whether it is what? Whether it is a variable quantity or not. Then the next thing we want to look at is quantity 2. So quantity 2, well, let's see what quantity 2 is. So quantity 2 is the number of what? The number of bricks required. So the number of bricks required is the second quantity right there. Yes, that's the second quantity. Like that. So there we go. Now we can go ahead to investigate, okay? We can now investigate what we are talking about here. In terms of what? In terms of whether these quantities are what? Whether these quantities are variables or what? So the number of identical houses, well, can the number of houses increase or can it change? The number of houses, can it change? Or the number of houses is going to stay constant? Looking at a real life situation, you know, the population of people keeps on increasing. Every day someone is born in a hospital or somewhere possibly, and that person will grow, you know, and will want a house. So the number of houses will keep changing. And because of that, we call this what? A variable. Okay, or a variable quantity. How about the number of bricks? Well, the fact that the number of houses can change means the number of bricks will also change. And so bricks is also what? A variable quantity. You see that? Well, so now the other thing that we want to look at is what? Now, well, let's first finish this. So we will go to activity what? Activity 4, part what? Activity 4, part B. Activity 4, part B is to let us know how they are related. If they are related, are they related? Yes, these two are related. Then the third part is activity 4, part C. This one is part B. This other one is part C, like that. Now, the thing here is this. Oh yes, sorry for the short well, yeah, sorry for the short internet breakdown. I think we are getting right away. All right, now here we are now. We let me see if the screen is being shared, because that is what we are using. Or let me just share the screen again, because the short blackout got us problems. Yeah. So yes, for this question, which is question 4, the number of houses to be built and the number of bricks required. This was the question, the number of houses to be built and the number what? The number of bricks required. Yes, the number of houses to be built increases, that is changes as the number of what? So the two quantities being the number of houses or the number of identical houses and the number of bricks required. We have seen that all these one change, okay? They are known as variable quantities, they can change. And the other thing is that when it comes to activity B, to see how they're related, yes, these two are related nicely because the number of bricks required for a house increases with what? Increases with the number of houses required, because more houses mean more bricks, because we use bricks for making what? For making houses. And for part C, yeah, that is how we describe it. How are they related? So we say the more the number of bricks, okay, the more the number of houses, okay, the more the what? The bricks required. The more the bricks. Yes, yeah, like that. So the more the number of houses to be built, the more the number of bricks, okay, like that. Now, activity 5 is about the number of learners at a school and the length of school day. That is, now I would like you to try this out. Please just get time and try to understand this. The number of learners at school and the length of school day. The length of school day means the time for a school day, okay? So now you have to identify. Please go ahead and do that. Identify the two quantities. Then tell us, or just write it down, whether you think the two quantities are all constants, or one changes as the other one is also changing, or one changes as the other one is not changing. Then in the second part, that is part B, illustrate, say yes or no if the two quantities are related. Then in the third part, if they are related, how are they related? If they are not related, say not applicable. So now in the next question, which is question 6, you also have what? The number of learners at school and the number of classrooms needed. Yes. Also identify the quantities. After identifying the quantities, the next thing is what? The next thing is for you to say which one is a constant quantity and which one changes with time, or which one changes relative to the other. Then after that, you will do what? You will move on to the second part, which is part B, if they are directly related. Then part C, you will also say whether they are what? Whether they are directly related or they are not directly related. Now, there is this thing which we call the what? The flow diagrams. The flow diagrams, well, a relationship between two quantities can be shown with a flow diagram, such as those below. So this one here is called a flow diagram. Now, unfortunately, only some of the numbers can be shown on the flow diagram. Not everything can be shown on the flow diagram. Okay? This type of diagram is called a flow diagram. Now, here in part 1, we are supposed to calculate the output for the flow diagrams below. Some input numbers are missing. So choose and insert what your own input number is going to be. Now, some definitions here. Each input number in the flow diagram has a corresponding output number. The input number corresponds to the first, okay, the first input number corresponds to the first output number in that order. And plus 5 is called the operator, meaning we have 3 here. When we add 5 to 8, we must get 8. So what is this number here? When you add to 5, you get 7. See that type of thing? Well, let's see how we can bring this. Now I'm going to place my board for writing quite close to this so that we have everything captured right here. All right, so there we go. Now we are moving on to what? We are moving on to something else. This time, the flow diagrams. For what? Flow diagrams. So how does the flow diagram work? Well, for this first diagram, the operator is 5. That means for every number on the left, there is what? There is addition. Well, what should that mean for every number on the right? You could think of the exact opposite. So if for every number on the left, there is addition, okay, you have to add 5 to it. That means for every number on the right, you must do what? Do the opposite of adding 5 if you want to get what is on the left. You see, adding 5 is the opposite of subtracting 5. So for the first one, we have what? We have 3, and to it we are adding 5. What do we get? Well, we get 8. Supposing that was not given, okay? Let's say it wasn't given. Then we could, let me see. Let me use this symbol here to illustrate something. All right. This is what I would like to put. I would like to put this. Yes, okay. All right, so there we go. Now, that means if this 3 was not given, and we are required to use what is on the right-hand side to get the 3, we would have to minus, or we would have to subtract 5 from 8 to get the 3. And if 8 was not given, okay? If 8 was not given, that means we were going to do what? We were going to add 5 to 3 to get 8. You see the thing? That is what I'm talking about. So for left-hand side, okay? Here, if we want to get something on the right-hand side, we minus. If we want to get something on the left-hand side, we plus. Basically that. And the flow diagrams, you know, it's not a difficult thing. Okay, so to get the number on the left-hand side, we say left-hand side. This is what we do. Then on the right-hand side, let me have it here. On the right-hand side, to get the number on the right-hand side, we just minus. Yes, we just minus. To get the number on the right-hand side, we minus. How do we do it? Rather we plus, we don't minus, we just plus. So we get the number on the left, to it, we add 5. Okay, that's what we are going to get. So that's very much like a general rule which we are going to be using. So now we don't have a number on the left. That means we have to minus on the what? On the right-hand side. It's very much like saying the number on the left. If we add 5 to it, we must get what? 7. What that means is to get the number on the left, we must, from 8, we minus 5 because the operator will not change. It stays plus 5. What is that? That's going to be 2. So you see, we have 2 here. When you add 2 to 5, you get 7. When you subtract 5 from 7, you get 2. Then we have 1. When we add 1 to 5, what do we get? We get 6. Okay? So for the next activity, we are going to add 1 to what? To 5. What do we get? We get 6. Then we carry on like that. So here we have 0 next. So 0, when we add 5 to it, what do we get? We get 5. The next number is -1. So when we have -1, the operator is what? +5. When we do that, what do we get? We get 4, because -1 plus 5 is the same as 5 minus 1. And so that gives us what? Negative. That gives us +4. You could also write it like this. Sometimes dealing with these minus things disturb you guys. So we could do this. We could have -1 plus 5. You see, it gives you 4 like that, but you have to write it nicely in the calculator. So the next thing is we don't have these 2. So what do? We just have to, well, we have to minus. How are we going to deal with this then? Oh, they gave us this one. So they want us to find the next 2 numbers. You know, here it's decreasing from 3 to 2 to 1 to 0. It's decreasing by 1. That means it's going to be -2. So we'll have -2 that we have to add to 5. What do we get here? Well, this gives us 3. Then we move on to what? The next number, which is -3. -3, okay? When we add 5 to it, what do we get? Well, this is going to give us 2. How did we get -3 here? We had to check the pattern here. The pattern is that we have to minus 1, or we have to subtract 1 from the previous number. So when we subtract 1 from this, we get 2. We subtract 1, we get 1. We subtract 1, we get 0. We subtract 1, we get -1. We subtract 1, we get -2. We subtract 1, we get minus what? -3. That is how this flow diagram works. Well, what type of numbers are given in the input? These are called integers, okay? The type of numbers are known as integers. They can either be positive numbers or negative numbers. Well, what's the next question then? In the above flow diagram, the output number 8 corresponds to the input number 3 complete. We did that already. In the relationship shown in the above flow diagram, the output number corresponds to the output number corresponds to -1. We did this already. The input number, we completed this. Yes, we completed it. Now this is your activity, guys. So you're going to do activity 2. You are supposed to complete this. The operator is what? Is -5. So as an example, what you do is you put 7 minus 5. What you get, you write here. You do the same for all this one. 6 minus 5, you write. 5 minus 5, you write. You know, all the things, you put it here. That is how you're going to complete this, okay? Well, let me check if question C is there. Could be, no, question C is not there. Then maybe, question 3. Question 3, let's put 3 to be the last number for you to try. So please go ahead and try question 3. The operator for question 3 part A is -5. That means you put -5 after -100. So you'll be having -100 minus 5, you write it here. Okay, -100 minus 5. How do you write that? Well, let me put this one here. For the first one, we are going to be having what? -105, okay? -105 minus 5, like that. And you write it. That's 101 for the first one. So you write it here. Then -100 minus 5, then -15 minus 5. You do that. Then for this one, you have to find the relationship yourself. What do you do to -23 to get this? Okay, what do you do to this to get that? You see, so they have given you 2 pairs, this one here, -23, and this, and also this and that. So you can use that to establish the relationship. The easiest way is to try to do what? Well, to try to to see how these two quantities are related. Can we add something here to get that? That is what we are going to put here. Okay? So it's like we have -3 plus something to give us 45. So the equation is going to be -23, okay, plus something should give us 45. That's what we have that side. So that means this something we are talking about is going to be what? It's going to be 45 plus 23, which is what? 45 plus 23, yes, which is going to be 68. So the value of x is what? Is 68. So that is the operator. The operator is what? Is plus 68. Okay, so you put plus 68 and you see what you find there. Everything will, so you have to put plus 68 here and it will help you to find this and that one. And that also brings us to the what? To the end of our discussion of today.